Hello everyone, welcome to the video on numericals on bipolar HVDC transmission line. Read the statement of the today's problem. A bipolar HVDC transmission line system from Chandrapur to Padge. So this line is installed in the Maharashtra from Chandrapur to Padge. The specifications of these lines are given. What are the specifications of these lines are given? The specification is rated DC bus voltage is equal to plus minus 500 kV, as the line is a bipolar, plus 500 kV one pole and minus 500 kV another pole. Power transfer is 1500 megawatt. Line resistance per pole per kilometer is 0.0105 ohm per kilometer. The resistance is given in per kilometer. Total line length is given as 752 kilometer. And input to the AC voltage line is 400 kV. That is, HVDC bus is connected to the 400 kV. So in this case, we have to calculate the DC current, DC line current per pole, DC line power loss per pole, then DC power delivered per pole and the total power at inverter end. So we have to calculate the power delivered at the inverter end, total as well as per pole power. Then DC voltage at inverter end per pole, DC voltage of rectifier 6 pulse bridge and DC voltage of inverter 6 pulse bridge. Okay, so these things we have to calculate in this problem. So let's see what is the configuration of our HVDC line. So if we look to the configuration of this HVDC line, so let this pole is at Chandrapur, that is at the rectifier station, and this station is at Padagi, which is in near Mumbai. So this line is rated as a plus 500 kilovolt. This line is rated as a minus 500 kilovolt. These voltages are with respect to ground, that is at zero potential. So this station is the rectifier station, this station is the inverter station. The resistance of this line is given as 0.0105 ohm per kilometer. This is the resistance given. And total length of the line is 752 kilometer. So in this case, we have to calculate all these values. So let's draw the equivalent diagram. So you can see that this is a 12 pulse converter. Out of this 6 pulse converter is shown here. 6 pulse converter is shown here. For a pole 2, this is a 6 pole and this is the 6 pole. So voltage at this end is a plus 500, voltage at this end is the minus 500 kV. So let me correct it. It is a minus 500 kV and voltage at this bus is equal to 500 kV. Okay, so and the power transfer is a 1500 megawatt, 1500 megawatt to the both lines means this line can transfer the power of 750 megawatt. So power transfer from the rectifier station, that is from this station, is a 750 megawatt, and power transfer from this station is also 750 megawatt. 750 megawatt. So total is 1500 megawatt. So on AC side, this bus is connected to 400 kV supply. On this side also, this bus is at 400 kV supply. So in this case, we have to calculate the DC line current per pole, and these calculations we have to calculate. So let us begin for the calculations. Let me pause for some while. So let us calculate the current. So here we have to calculate the current per pole. So power per pole must be known, which is a 750 megawatt. How we can calculate this DC current? So the DC current ID is equal to PD total power transfer divided by 2, that is the per pole power, divided by VD. So here the total power transfer is 1500 megawatt divided by 2 upon 500. So if we calculate this power, as the power is in mega and voltage is in kilo, you will get the current is in terms of kilo ampere. It is 1.5 kilo ampere. Now let me increase somewhat the font size that is very visible to you. Now we have to calculate power loss per pole. So power loss per pole. Okay, so while doing the power loss per pole current is ID square, into resistance of the one pole is RD. So R ID square means 1.5 square multiplied by resistance of the one pole is 0.0105 ohm per kilometer, but length of the line is 752 kilometers. So it comes to 17.766 megawatt. Why it is coming in a megawatt? Because the current is in kilo ampere. So kilo square will be equal to mega. Hence the power will come in the megawatt. Now we have to calculate the power delivered per pole and total power at inverter end. So at the inverter side, what will be the power? At the inverter side, the power will be equal to, we want to determine the per pole. So let me write, it is the per pole. Okay, so per pole power. So this per pole power is equal to, so how much per pole power will get? So what is the total power transfer? The total power transfer is a 750 megawatt. Out of that, the 17.766 is vested in the one pole. So the total remaining power is the 732.234 megawatt. This much power will be transferred through uh, one pole. So that is, and one pole at the receiving end, you will observe that the total power is 732.234 megawatt. Remaining will go in the loss in the transmission line. So what is the total power transfer? The total power transfer at inverter end is 2 into 732.3234. So calculate this answer, how much you are getting, tell me in the comment box. Okay, so how much megawatt will be power transfer? You can tell me in the comment box. So this is what the power delivered at the inverter end. Okay, so you can observe, we have this voltage is equal to 500 kV, and this voltage is also 500 kV, and the line resistance is calculated as 0.0105 multiplied by 752 kilometer. This is the line resistance. So let us proceed for the next section of the problem. In the next section of the problem, we have to calculate a DC voltage at inverter end. So we determine that this voltage is equal to 500 kV, and the current which is flowing from this is the 1.5 kilo ampere, and the resistance of the line is 0.0105 multiplied by 752 kilometers. So we have to calculate the voltage at inverter end. So voltage at inverter end per pole, so it is VDI, is equal to VDR minus ID into RD. Simple, we have to apply the KVL here. So it is a 500 minus, what is the value of ID? ID is 1.5 multiplied with 0.0105 into 752. If we calculate this voltage, you will get this voltage as, this value of the voltage is 488.156 kV, 488.156 kV. Now we have to calculate the DC voltage of a rectifier 6 pulse bridge. So we know that this is the output of 6 pulse bridge, this is the output of 6 pulse bridge, this is the output of 6 pulse bridge, 6 pulse bridge. So 12 plus bridge are connected in a cascade position. So what is the output of the 6 pulse bridge? Obviously voltage of rectifier end for a 6 pulse is equal to voltage of the rectifier, total voltage of the rectifier divided by 2. So it is a 500 divided by 2. It comes to 250 kV. Similarly, what is the voltage at inverter end 6 pulse bridge? So VDI, okay, VDI at a 6 pole is equal to VDI divided by 2, that is 488.156 divided by 2. It comes to 244.08 kV. So at this end, this total voltage is 488, whereas out of this 1 6 pulse we have the voltage of 244. Another is also have 244. Likewise, you will get the output. So by drawing the equivalent circuit diagram, the problem can be solved easily. So hope you understand this problem. If you like this problem, please give me like, and if you have any query, you can post in the comment box also. With this, Thank you very much.